Hello and welcome back. We're still on algebraic expressions. In this video we're going to be looking for what we call the lowest common multiple. So we're going to be using this example to illustrate how we find the LCM, the lowest common multiple for given algebraic expressions. So we have the question: find the lowest common multiple LCM of the following. On part A we have 12xy cubed and 15x squared y to the power of 4, and on part B we have 98p cubed q squared and 28p squared qr to the power of 4. Right, so let's go on to the solution. But before we start our working, I want you to remember these things which are very important. You need to know that the LCM is the smallest number in which two or more numbers divide exactly. So that's what we call the LCM. And also when you're looking for the LCM, first express the terms as products of factors in index form. That's also another very important thing. We were doing this even when we were looking for the HCF in the previous lesson. Alright, so we want to start our working with part A. Okay, so let's start. Alright, so in part A we have 12xy cubed, and we also have 15x squared y to the power of 4. So what did we say we do? We first express the terms as products of factors. So we have 12 as products of factors gives us 2 squared multiplied by 3. Remember, 12 is actually 2 multiplied by 2 multiplied by 3, but in index form that means that 2 multiplied by 2 will come out as 2 squared. So that's also important for you to always know. So that's multiplied by x multiplied by y cubed. We also go for 15. 15 as prime factors is 3 multiplied by 5, and that's multiplied by x squared by y to the power of 4. So for the LCM, the lowest common multiple, what do we do? Now you need to understand this. What you do is, for the LCM, you collect all the factors represented. You see we have all these factors for the two algebraic expressions. Now what we are saying here is all these factors must be represented in the LCM, and also for common factors, take the one with the highest power. Here I'm talking about the terms that have the same base, that have a common base. You take the one with the highest power. So if we go on to our factors for 12x squared y cubed and 15x squared y to the power of 4, since we are told to collect all factors represented, so we start with the terms that have the base 2. So we look at 2 squared, and there is no other term on the other set of factors that has the same base, so we have to represent 2 squared in the LCM. And then we also see here that 3 is common, that's 3 to the power of 1. So what we do with the common factors, we just take 1, and we said we take the one with the highest power. Since they have the same power, 1, we just take 3 to the power of 1. Right? For the term with base 5, we only have 1, so it has to be represented in the LCM, so we just take 5. For the terms in x, we have x to the power of 1 and x squared. We take the one with the highest power, and that is x squared. And we also do the same for the term in with base y, that's y cubed and y to the power of 4. We take the one with the highest power, that is y to the power of 4. So you need to understand these are very, very important points right here. Alright, so we now just simplify what we have. So 2 squared multiplied by 3, 2 squared is 4 multiplied by 3, that's 12, and 12 multiplied by 5 gives us 60. So we're going to be having 60x squared y to the power of 4, and that's the solution to part A. Right, so I just hope you understood what we did here on part A. I'm giving you part B to work out, and I'm gonna be giving you just 2 minutes to complete it. So remember, on part B we have 98p cubed q squared and 28p squared qr to the power of 4. I want you to pause the video and start working from now. So this is how we do it. We start with 98p cubed q squared. We look for the prime factors of 98 first. We cover this in another video of how to look for the prime factors. So I'll also give you the link to the other video so that you may make sure that you now know how to express numbers as products of their prime factors. So for 98, as the product of its prime factors in index form, we have 2 multiplied by 7 squared, and that's multiplied by p cubed by q squared. We do the same for 28p squared qr to the power of 4. We have 28 as 2 squared multiplied by 7 multiplied by p squared by q by r to the power of 4. So we have now written both algebraic terms that we have as products of their factors. Now we want to look for the LCM. Remember what we said. We said you collect all the factors represented. We also said that for the common factors, or for the terms with the common base, you take the one with the highest power. Very important. So we are saying LCM is equal to, we go on to the ones with the base 2. We have 2 to the power of 1 and to the power of 2. These are common. We take the one with the highest power. We take 2 squared. For 7 squared and 7, they are also common. The base is common, so we take the one with the highest power. We take 7 squared. For the terms in p, we have p cubed and p squared. What do we take? P cubed. Again, we go on to q squared and q to the power of 1. We take the one with the highest power. We take q squared. And for r to the power of 4, r to the power of 4 is not common because we do not have any term in r for 98p p cubed q squared. But since all the factors must be represented in the LCM, so we simply take the r to the power of 4. So we then simplify this, and what do we get? We get 196 p cubed q squared r to the power of 4 for our LCM. And I hope you got the answer correct. So I'm going to be giving you more examples to work out so that you have more practice on how we look for the LCM.